Hello. This discussion we're going to determine the amplitude and the period of a sinusoidal functions in a more formal way. The last couple of discussions we have discussed the amplitude. I called it the stretch, but the stretch is the amplitude when you're dealing with sine and cosine functions. So let's look at a couple of graphs here. Y equals the cosine of x. If you look at this graph, the amplitude is 1. Okay, and so this is a typical cosine curve. If you multiply it by 2 times the cosine of x, look how high it goes. The shape still has the same x-intercepts, pi over 2, 3 pi over 2. The low point still occurs in the same place, pi and negative pi. The high points still occur in the same place at 0 and 2 pi. The only thing different is it's the stretch, it's the height of the graph. So instead of having an amplitude of 1, having an amplitude of 2 makes it a lot steeper. So the peaks, in this case, are twice as high and the valleys are twice as low. So that's what they look like. All right. So if you look at the amplitude of a sine graph, y equals a times the sine of ax, this is the shape of it's going to be. Notice they don't call it 1 and negative 1. They call it a and negative a. So that's typical what you could do. So if you have a 7 times the sine of x, then the scale would be 7 down to negative 7. So a is greater than 0 though. Because if a was negative, you have to flip it over. All right, so we look at the cosine curve again. All right, and look at this one. Y equals cosine of 3x. Now look where the 3 is at. Okay, the 3 is inside. So in order to figure out what the period is here, you got to take you replace the x with 3x. So in essence, what you're doing here is you're restricting the period to 1/3 as much. Now I like a little formula. So here I just use a formula. The formula is going to be 2 pi divided by omega. And that's how you can tell where the graph is going to end. So take 2 pi, divide by omega, which in this case omega is 3. And it works with sine graph just as easy. And a couple of videos, a couple of discussions before this, we actually use that formula. So it's 2 pi divided by omega, in this case 2 pi divided by 3. So what that basically means is the cosine curve here will complete its cycle in 2 pi over 3. And it does. Look at the second graph down here. It starts at 1. When does it hit 1 again? Well, you go past pi over 6, past pi over 2, past all those x-intercepts, and go all the way up to 2 pi over 3, comma 1. And now you're going to start over again. So it starts at 0, ends at 2 pi over 3. So that's its period at 2 pi over 3. The reason you know it's 2 pi over 3 is because you take the 2 pi and divide it by the omega, in this case 3. So now, and what they do is they show you a little bit more of the graph than you really need to see, but that's it. So you started at 1, ended at 2 pi over 3, comma 1. Really, that's all I want to see, is that one period. The excess to the left and the excess to the right of those of that graph, I don't need to see that. I just want to see the part of the graph that starts at 0, 1, and ends at 2 pi over 3, comma 1. That's really all I want to see. Okay? So if you have a times the sine of omega x, a greater than 0, and omega greater than 0, the period is 2 pi over omega, which is what I just said. 2 pi over omega. And if w is greater than 0, the amplitude and the period of these two graphs are the absolute value of a is the amplitude, and the period is 2 pi over omega. So this, we've used this before in a previous discussion. It just wasn't formalized until now. All right. So let's look at an example of doing this. So we're going to determine the amplitude and the period of y equals negative 4 times the cosine of 3x. Now what's the amplitude? If you said negative 4, it's close, but it's not quite right. Amplitude is a distance. So the amplitude is actually 4. Okay? The reason the negative, what do you deal with the negative? The negative, all the negative does is it turns the graph upside down. So this cosine graph will be an upside down cosine. It's been reflected across the x-axis. Okay? So it still has the amplitude of 4 though. The period is 2 pi over the absolute value of omega. So in this case, 2 pi over 3. Alrighty? Now, you want to see the graph? We're not asked to see the graph here, but what would the graph look like? Well, it's going to be an amplitude of 4, 2 pi over 3. We already had that shape a while ago. We know what ended there, but it's upside down because of the negative 4. So that's what it looks like. So it starts down there at 0, comma, negative 4. It'll end at 2 pi over 3, comma, negative 4. Halfway in the middle is pi over 3, and that's where it reaches its highest point. Now, I don't have it labeled here, but what are the x-intercepts? Well, what's halfway between 0 and pi over 3? Pi over 6. So pi over 6 is basically the scale here. So it's going to be pi over 6, 2 pi over 6, and 3 pi over 6 is the next x-intercept. So at 3 pi over 6 is also known as pi over 2. Now again, it's turned upside down because of the 4, because of the negative 4. Alrighty, so that's what the shape of this graph looks like. Okay, and again, I like just seeing the one cycle of the graph, the one period. That's all I want. When you're doing a test, that's all I want to see is this. Like, that way you won't get confused with the sine graph, and neither will I. And so that way we're talking about the same thing. Okay? All right. So this ends this discussion. If you have any questions on it, you let me know, and you have a good day.